All right, so we are going to be looking at slope, and more specifically slope in a table, graph, equation, and some key things you can look for when working for word problems. So I want to do a brief overview of slope in general. So up top here, I have 3 different representations of the same exact equation. So this table is a table for this equation. That's a graph for this equation, and this equation represents all of those. So we're going to be looking at slope for each and every one of these and making sure that these 3 have the same slope. So first, let's do how to find slope in the table. So I'm actually going to jump down here, and we'll jump back up here in a second. I'm going to jump down here. When we're finding slope in a table, you just need to choose 2 coordinate points. So maybe you want to choose -3 and 7, and then choose 0 and -7. Maybe you want to choose -3 and 7, and then 3 and -21. Doesn't matter which 2 you choose, as long as you choose 2. So I'm actually going to go ahead and choose 0, -7, and 3, -21. So a couple ways we can find slope here. The most common method is to use kind of like what I like to call like a jump method, where you draw arrows going the same direction. So going from -7 to -21. And since that one's going to the right, this arrow is also going to go to the right as well. And you need to ask yourself, okay, how do I go from -7 to -21? What can I add or subtract to -7 to get to -21? Well, if we're looking at this on a number line, -21 is more left than -7, meaning we're subtracting. It's more towards negative infinity. So I'm going to be subtracting something. And you can do this in your calculator, or maybe you want to try and do it in your head. I know that -7 minus 14 equals -21. So that's my jump here, is -14 for my y's. For my x's, on the other hand, I'm going to start where my arrow started, 0, and ask myself, what can I add or subtract to get to 3? This one's pretty straightforward. I know that 0 plus 3 equals 3. And here's a common issue. When we're writing our slope, sometimes we forget that slope is the change in y. There we go. Over the change in x. Sometimes we flip-flop it. But we're doing our change in y first, meaning I'm going to look at where my y is, and I'm going to take that change, which was -14, put that on top, divided by my change in x. I'm going to go to x and see, oh, my change in x was 3. And then if possible, we're going to simplify it. But in this case, 14 divided by 3, my calculator doesn't give me a pretty number. It doesn't even simplify as a fraction. So we're going to leave it as that. Another method that you might want to do when working with a table is using a formula. So I'm actually going to draw a little squiggly line. So change in y divided by the change in x. We can represent that by saying that's y2 minus y1 divided by x2 minus x1. All right. So let's go ahead and choose coordinate points. I'm going to choose 2 different ones this time. I'm going to choose the points -3 and 7. And let's do 0 and 7. Sorry, 0 and -7. So what these subscripts mean in this equation, again, it's showing that I'm taking the 2 y's and I'm finding the change in them, the difference in them, divided by the change in x. So notice how the subscripts 1 and 2, these just represent different equations. So I'm going to label this first equation 1 and the second equation 2. But it doesn't matter which is which, as long as you're consistent. Something else that might be important to write down, if you get confused, is your coordinate point is in the form x comma y. So x comes first and then y. From here, we're just plugging in and simplifying. So y sub 2 means I'm going to go look at y's. So I'm going to look at these 2. And I'm going to find out which one has the 2 next to it. And it happens to be this -7. So I'm going to list -7 first. minus y1. So I'm going to go to y and 1, and that happens to be 7. Divided by x sub 2. So I'm going to go to x now and go to my 2. It happens to be 0. Minus, put that minus there first, and then go to x sub 1. So x1 is negative 3. So notice I'm subtracting a negative. That's okay. That's just another fancy way of saying, hey, we're going to take that minus a negative and make it a big plus. So I'm actually going to rewrite this as plus 3. All right, let's simplify. So negative 7 minus 7, well, I know that's negative 14. Divided by 0 plus 3, that one's easy. That one's just 3. And since it cannot be simplified, that is our slope, which matches up with the other method that we used over here. So keeping that in mind, let's jump back up to our first initial table up here. So we can use either one of these methods, but I'm going to go ahead and use the arrows because I think that makes a little bit more sense in my brain. So I'm going to choose the first two and draw my arrows going down. All right, so how do I go from 3 to 2? Well, I know I'm going to go backwards. I'm going to subtract, and I'm going to subtract 1. To get from negative 4 to negative 2, even though those negatives are in there, we can't let those trip us up. I know that that's more positive. Negative 2 is more positive. So I'm going to be adding, and I'm going to be adding 2. And remember, we talked about down here, slope is the change in y divided by the change in x. Well, over here, my y changes by negative 1. I'm going to put m equals negative 1 divided by my change in x, which is 2. So my slope is negative 1/2, which could be written various different ways. Maybe you want to make the negative sign out front, or you want to make the negative sign down with the 2. Maybe you went the opposite direction. Maybe you went this way, so you drew your arrows going up. Then that's how you'd get that answer. Moving on, let's flip-flop back down here to the graph. So for this graph, graphs are personally my favorite to find slope with because we just take the rise over the run. And what do I mean by that? I just mean change in y divided by the change in x. All right, so I'm going to pick 2 points on the graph. And again, I'm going to look where the grid lines intersect to find the best point. So here's a good point. And let's see, where did the grid lines intersect? Oh, here they are. So let's look at the rise over the run here, or the change in y over the change in x. So once you have 2 points, you're going to take your pencil and start at either of them. I like to start with the left point. It makes a little bit more sense to me. So go left to right like we read. So if I'm moving my finger along, this is my first point. And my rise. So I'm going to go up with my pencil until I find that I'm on the same level as my second point. So here we go. And in that case, I went up 1, 2, 3, 4 units. And since I'm going up, I'm going positive 4 units. Now, once I'm on the same level, I need to then turn my, I don't know if you want to call it a race car or whatever you're envisioning when you do this, to the right. And I end up going 1 unit to the right. So I rise 4, and I run 1. But wait a second, what's 4 divided by 1? That's just 4.